Hello all, and thank you for listening to Mr. Laxton's video on this Algebra 2 Section 1.1 Notes video. Before we get started, before we get in here, do me a favor and hit the subscribe button. I'm not much of a YouTube guy myself, but I know that every single YouTube video that I watch, they say hit the subscribe button, so I don't know. But I'm guessing that gives you guys the opportunity to see more of my videos when I post them, different things like that. So please, do me a favor, hit the subscribe. Alright, so as we get into section 1.1 here, we're looking at my essential question to start us off here. What are the different types of real numbers and the properties of addition and multiplication? So those are kind of the two topics that we're looking at here. This first section, we're really not going to get totally into the solving or the graphing or anything like that quite yet. We got to learn some back knowledge before we push on all that stuff. All right, the first one is the natural numbers. All right, these are different types of real numbers. The natural numbers are the counting numbers, like 1, 2, 3, or 4. Okay, notice I just kind of like the counting numbers are just the natural numbers are just on your natural hand. That's what I like to think of it. My natural hand is personally for me my right hand. So my natural numbers, I start off, I can count my fingers like a 1, 2, 3, 4, 5, and then 6, 7, 8, all the way up to infinity. All these real whole numbers. Okay, and my natural numbers, notice they don't include 0. It just starts with 1, 2, 3, 4, 5, 6, 7, and so on. All right. You don't start by counting the fingers. You don't start with counting by 0. You start by counting with 1. So natural numbers, my natural hand. That's how I like to remember it. All right, whole numbers are the natural numbers. So they are the natural numbers, including 0. All right, so I just kind of talked about, hey, my natural numbers, you don't start counting with 0. You go 1, 2, 3, 4, 5, and so on. But my whole numbers, they do actually include that 0. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 17, 27, 121, all those numbers. All right, my integers are all my positive and negative natural numbers. Ooh, natural. There's Mr. Laxton spelling the first time all year. Natural numbers along with 0. So these are positive and negative numbers are integers. So negative 17, positive 27, negative 113. All those positive and negative natural numbers with 0. All right, my rational numbers are numbers that can be written as fractions of integers with denominators not equal to 0. Remember, we can't divide anything by 0, so the denominators can't be 0. So these examples are like 1/2, negative 3/8, 9/5, 14/7. That would be 2. So that is a rational number. So notice that all those guys work. So my decimal approximation ends. That's the main thing here. So if I look at 1/2, that decimal approximation is 0.5. All right, it ends right there. It's done. It's 0.5. All right. If I look at the fraction 10/2, that is a rational number. So if I look at that, that simplifies to just 5. Look at that. It ends. It's done. It doesn't keep going. It's done. All right, so rational numbers, decimal approximation ends. Irrational numbers, on the other hand, are numbers that cannot be written as a quotient of two integers. So this cannot be written as a fraction. A quotient is the same thing as a fraction, so they can't be written as a fraction. All right, so famous numbers of these, the square root of 2, the square root of 3. Kind of the most famous one you'll ever see here, and the one that a lot of people think of is pi. All right, so the pi, the decimal approximation, does not end. If you guys look over the top of my whiteboard in my classroom, you guys see 3.14159, and it keeps going on and on forever all the way around my classroom. All right, the decimal approximation never ends. All right, so rational numbers end. Irrational numbers never end. All right, goes on forever. All right, so real numbers are all numbers on the number line. that are either rational or irrational. So if I look at this, if I just draw my number line, you can draw any number line in the world. I'm going to put 0 in the middle, and I can go 1, 2, 3, 4, 5. I go negative 1, 2, 3, 4, 5. So this is negative 5. This is positive 5. Any number on this number line is a real number. So if I look at here, this number is approximately negative 1 to like 2.5. All right, negative 2.5, that is a real number. Negative 2.5573326, numbers that go on and on forever, are also on the number line, so those are real numbers. All right, so all these guys up here, natural numbers, whole numbers, integers, rational, irrational, are all real numbers. All right, we're going to talk briefly this year about numbers that are not real. So we're going to talk about this. That's like the square root of a negative number, like square root of negative 7 is not real. So this is not real. We're going to talk about that in chapter 7, all right, in Algebra 2. All right, but until then, we're looking at real numbers. All right, so let's keep on going here. My properties of addition and multiplication. So a bunch of different properties here. This first one that we're looking at is commutative. This one has properties of addition and multiplication. Okay, so commutative does not matter which order that you add or subtract numbers in. So notice here for this first one, I have a plus b is the same or is equal to b plus a. So you notice here that, hey, these guys flip around. Okay, notice over here it's the same thing. A times b is the same thing as b times a. All right. So I just have a real quick couple examples here. 5 plus 2, obviously here 7, and you can look at the other way is 2 plus 5 is still 7. All right, that's commutative. All right, same thing with multiplication. If I have 2 times 5, that is 10. All right, 5 times 2 is also 10. So commutative. Doesn't matter which order you add or subtract or add or multiply things, it gives you the same answer. And this doesn't work for subtraction. So look here, that's why there's not a commutative of subtraction, because 7 minus 2 is 5. 2 minus 7 is negative 5. So these guys are not equal to each other. So subtraction is not commutative. All right, associative properties. Again, these guys have addition and multiplication. It's kind of the same deal as commutative, but now it's got 3 numbers. All right, so associative says that, hey, if I do in my parentheses first b plus c, it's the same thing as if I do my parentheses around my a plus b, or if I multiply things over here. It does not matter in which order you group them in. If it's all multiplication or if it's all addition, it's going to give you the same number. So if I look at these couple examples here, I know that 2 plus 5, because I got to do my parentheses first. We're going to talk about that in the next section. That is 7, but I also know that 3 plus 7 is 10. But now let's go the other way around. If I go 3 plus 2, that gives me 5. But now I know 5 plus 5, hey, that's also 10. All right, so it's associative. It doesn't matter which way those 3 numbers talk to each other, which one talks to each other first. You still come out with the same number there. All right, the next one, multiplication. This one's pretty straightforward. 2 times 5 is 10. 3 times 10 is 30. All right, 3 times 2 is 6. Times 5 is also 30. So notice, hey, these guys are equal to each other. All right, associative, adding, subtract, or adding and multiplying. Doesn't matter which way you do those 3 numbers. All right, identity. All right, so notice we have identity property of addition and we have identity property of multiplication. The way I like to remember these two is you cannot change your identity. All right, you cannot change your identity. So notice here is that when I add 0 to something, hey, it just shoots out that something. All right, so I cannot change my identity. So if I take 4 plus 0, that's going to give me 4. Notice, hey, 4 stays. I didn't change anything. 4 starts, 4 ends. All right, I didn't change my identity. Identity property of multiplication is that a product of any number and 1 is that number. So now notice it's not 0, it's 1. So if I multiply any number by 1, it gives me that same number. So 5 times 1 is 5. You cannot change your identity. 5 shoots out. All right, inverse property of addition and inverse property of multiplication. So inverse property of addition is when you take the sum of a number and its opposite. Okay, so that's its additive inverse. So let's say here if I have 5, the additive inverse or the opposite of 5 is going to be -5. All right, so if I look at this example, I have 3 plus -3, that gives me 0 every single time. So if I add something with its opposite or its additive inverse, it gives me 0. Okay, the inverse property of multiplication is when I multiply a number in its reciprocal. Okay, so that reciprocal, if I look at 5, the reciprocal of 5 is 1 over 5. So I kind of can write this as a fraction. These guys flip around. That's my reciprocal. All right, so notice here that if I take 3 and I multiply it by its reciprocal 1/3, that's going to give me 1 every single time. All right, inverse property of multiplication. All right, distributive property. You guys have seen this a lot in Algebra 1. If you guys see here, I'm not going to spend a whole lot of time on this. You can just distribute that number that's outside of the parentheses. So A needs to be multiplied with the B. So this turns into A times B plus A times C. All right, there's a bunch of different ways people think about these. Beyonce waves or something. I'm not really quite into that. I don't know. But hey, I call it sprinkle. I like to sprinkle that number on the outside in. All right, here we go. Let's just look at these two examples. If I sprinkle that 2 in there, 2 times 3 is 6. And then I have 2 times 6 is 12, which gives me 18. All right, so notice here that, hey, this is 18, this is 18. Here we go. I go 3 times 5, which is 15, minus 3 times 2 is 6, which gives me 9. All right, and now down here I go 15 minus 6, which gives me 9. All right, pretty straightforward there. You guys have seen that one. Be careful with these negatives. You do have to distribute that -2, so it's -1 times 2x plus -1 times 4, which is going to be -2x minus 4. If you have plus and -4, that's the same thing as well. All right, so again, thank you for listening to this video on the Section 1.1 notes for Algebra 2. Please stay tuned for the rest of the year, and we will get some Algebra 2 down. Thanks for listening. Make sure to hit that subscribe button.